Okay, class. Um, just do another problem dealing with method of joints. Still in chapter 5. So we're asked to determine the force in each member, right? And we are asked to state if the member is in tension or compression. So again, our support reactions are very important because it typically stabilizes our whole structure, whole frame. And this would reframes the frame from actually collapsing or falling apart. And again, these are static problems. Therefore, your structure should not move. Okay, and we use equilibrium equations, some of the forces in the x and y direction, some of the moments about a particular point of interest. Okay, so the first step really is to draw our free body diagram, which I have here. I'm showing all the forces acting on it. Here's your support reactions at point A and at point C. Okay, A has a pin, has two forces acting on it. C is a roller, has only one force acting on it. Okay, so let's move forward. If I wanted to um, implement my support reaction, or calculate, I'm sorry, my support reactions. Okay, so what I do is, since I'll just take some of the moments about point A, and the reason why I take moment about point A, I'm looking for a point where you have more than one force acting on it, and that's going to be point A. So those forces typically have no effect when you calculate a support reaction at that particular point. So it allows me to calculate other forces at other places or other support reactions acting on that particular structure. Okay, so some of my forces about point A. I'm sorry, some of the moments about point A. They're going to equal to 0, and I'm taking clockwise to be positive. So when I do that, I'm going to get um, negative cy times 6 feet, right? Plus, or let me just back up before I do that. If I were to remove, say for instance, I were to remove some of these structures here, okay? Now I just have a regular triangle, and this is a right-hand triangle right here. Well, I know this is 6 feet. I know this is 30 degrees. I can use my trigonometric function. I can use tan to find this height right here, and that height gives me nothing more than like 3.464 feet. Okay. Now, if I do that and I go back and implement or return my those particular frames, okay, and I have one coming up here. Okay. Well, I know this is 3 feet here, and this is 3.464 feet here. So now I could still use Pythagoras theorem, or I can use a trigonometric function to find this angle right here. And when I do, that's going to be, that happens to be like 49.1. And I forgot to share with you, if I were to move this line right here, just remove this line here, again, if I were to remove this line here, well, if this is 90 degrees, this is 30 degrees, this right here is going to be 60 degrees, okay? So if I put my line back in, I already said that this angle right here was 49.1. If that's 49.1, then this angle right here is going to be 40.9. Now, if this whole angle is 60 degrees, then this angle right here is going to be 19.1. Okay, so these are just some of the ways you can use your trigonometry and geometry to find certain aspects of a triangle. Okay, so I'm going to erase some of these components here so they don't get in the way. Okay, but just kind of keep those in mind. Okay, okay, okay. So going back to our moment about point A, and it's going to be plus 450. This 450. This is supposed to be 450, not 400. Okay, 450 pounds, and that's going to be times 3.464 feet equals 0. Let me just move this over. Okay, and equals 0. And if I solve for my CY, I'm going to get roughly 260 pounds. Okay. Then what I want to do is I want to be able to take the moments about point C equals 0. And that's going to be AY. AY here. This is my point of interest right here. And I'm 6 feet away from C. Okay. Minus my 600. It's my 600 pounds right here. And I am 6 feet away. That's going to go counterclockwise. Okay. Plus my 450. And I am actually from point C, I am actually 3.464 feet away. Okay, when I solve for AY, I'm going to get roughly 337.5 pounds. Okay. Let's just say that's going to be 340. Sorry, 340. 340 pounds. Okay. It all depends on how you round this number off right here. Because I rounded it off to 3.5. And so it kind of moves the end number a little bit off as well. But you're in the right ballpark. Okay. So I have my support reactions, AY, CY. And then I could use some of the forces in the X direction equals 0. Right. All the forces in the X direction, I have a negative AX plus 450 pounds equals 0. So AX equals 450 pounds. Okay. So I have AX, AY, and CY. AX, AY, and CY have all my support reactions. Okay. So my next step, step 3, I want to be able to calculate all the forces in each member. Okay. So let me just bring this over here. Okay. And now just take this out. And I can take this out here. Okay. And I can just move this a little bit upward. Okay. And then I could say I'm going to go with joint A first of all. Okay. So my joint is right here. Joint A. Let me move this over a little bit. And I have AX acting on it that way. I have an AY acting on it that way. I have FAB. And I have FAE. Okay. So when I do some of the forces in the Y direction, I know my AY was AY was 340. My AX was 450. Okay. So some of the forces in the Y direction is typically going to give me AY plus FAE equals 0. FAE equals 340 pounds, and that's going to be in compression. It's going to be a negative. Okay. Some of the forces in the X direction equals 0. Okay. That is going to be negative AX plus FAB equals 0. FAB happens to be 450 pounds, and that's going to be in tension. Okay. And now, let me look at joint C. I'm going to take this joint right here. Okay. So joint C. Let me bring this down again. So you can see it. And I'm going to erase this part here. Okay. So joint C is going to be down here. And I'm going to have, it's going to go that way. Then I have AY, and I'm going to have FBC. Okay. Well, it's 30 degrees, so I'm going to have F. This is going to be FCD. This is going to be FCD sine 30 degrees. And I'm going to have FCD cosine 30 degrees. Okay. And now when I do some of the forces in the Y direction equals 0. And this is going to be, our AY was what? Our AY for our support reaction was 340 degrees. 340 pounds. Okay. So some of the forces in the Y direction, I'm going to get AY plus FCD sine 30 degrees equals 0. Then my FCD equals 520 pounds. And that's going to be in compression because it's going to be a negative number. Okay. Now, if I do some of the forces in the X direction, equals 0, I'm going to get negative FBC minus FCD cosine 30 degrees. And that's about it. Equals 0, right? That's all the forces in the X direction. So my FBC happens to be 450 pounds, and that's going to be in tension. Okay. Then if I choose joint B as next, let me choose joint B. Okay. And I'm going to bring this one here. I'm going to paste this. Okay. I'm going to come up more. Get rid of this right here. And I'm going to come up a little bit more. Okay. Now if I choose joint B, that means here is my interest, my point of interest right here. So it's going to be B, right? Okay. So at joint B, I'm going to have quite a few forces act on it. This is F, BC. Okay. This is going to be here, F, BD. Okay. This is F, BE. And I have two forces again. So uh, since we're looking at this line right here, this is going to be 49.1 degrees from the x-axis. So that's going to be FBE sine 49.1 degrees. And we're going to have here FBE cosine 49.1. That doesn't look good. This is FBE cosine 49.1 degrees. And then we have another one coming off here, off that joint, and that's going to be FAB. Okay? So if we just do some of the forces in the x direction equals 0, what you're going to get is you're going to get FBE equals 0. And then, of course, when you do some of the forces in the y direction, you're going to get FBD equals 0. Okay? So these two are going to be equal to 0. These are zero-member forces. Okay? Then, if we go on to joint E, okay? So joint E, it's going to be a structure here. I have this 600 pounds coming down on that. And then I have another 450 pounds coming from the left. Okay? Then I have FDE. Okay? And this one, again, this one is going to be FDE. It's going to be cosine 30 degrees. And the reason why it's 30 degrees, because from here to here, this angle is going to be 30 degrees, which is equivalent to this angle right here, 30 degrees. Okay? And then this one comes down, FDE sine 30 degrees. Okay? Then we have FEB or FBE. Right? It's going to come down like this. It's FBE. And it also has FBE. It's going to be cosine 49.1 degrees. And the reason why, we're looking at this angle right here. Okay. And then we have FBE sine 49.1 degrees. And then lastly, we have our FAE. Okay. And this is going to be FAE. Okay. So when you do all of that, you now take some of the forces in the y direction equals 0. Okay, I have a negative FAE minus FBE sine 49.1 degrees. We know this goes to 0 because FBE here 0. Okay, and then let me just move this back a little bit more. And then I have minus FDE sine 30 degrees minus 600 equals 0. Okay, and then when I do the math, I get FDE equals 520 pounds. And that's going to be in tension. Okay, I hope this helps. Thank you very much for your time and your patience. Thank you. Bye-bye.